Okay, so this is my MIS 665 project. It took some time, but I guess we're here now. So let's get started. So the business understanding. So in addition to gaining the understanding of why a loan cancels, this company would like me to build a model predicting if a loan is going to cancel or not. So no means the loan didn't cancel. One means it did. So a little bit more understanding. So as an associate, as a financing company, it's important for you to take advantage of every opportunity given to you. In this case, the opportunity is to decide whether or not a loan may cancel, or if you'd even like to grant a loan based on cancellation criteria, which we're going to dive into. So business and data understanding. First of all, we're going to import our data set. Here's all of our data values. We had 48 columns and I believe 140,000 different data values. Here's a more in-depth description of each of the values. And then here's a little description. And at this point, we've imported all the data and we're looking for things that stick out for further analysis. So data processing, this is one of the more tricky parts of the data because of the abundance of values and variables, and then the large amount of null values, empty rows. And after picking through the variables with a large amount of empty values and using a little bit of background knowledge, I was able to narrow down the variables with the best chance of predicting whether a loan will cancel or not. The three criteria we used were correlation, classification, and clustering analysis, along with data visualization. So first off, I went to find some missing values, and I dropped the rows with a huge abundance of missing values, because if they didn't have enough values, it was kind of silly to even have them in the data set. So I dropped those, and then I kind of ciphered through which variables would be more important and which ones would be less important. And it may seem like a lot, but these are the ones I ended up canceling and deleting, and I was left with this data set of about 12 to 13. And here were the null values left, and I dropped the remaining null values, leaving me with about 34,000 different pieces of data. That's what I was left with. I dropped duplicates, and at this point I filtered through any variables that seemed unimportant or had too many missing values. And so the one thing that I did do was under borrower credit score, there was an NS value, meaning no score. So I categorized that as 6 and used 6 because 5 was the worst credit score rating, and 6 means no score, and so no score isn't really a good thing in the financing company, so you want to have a credit score, so I put it up there with the worser values. And then risk score, I just changed these letter variables to numeric values, like so. And then so that's basically what I did, and I changed the rest of the values to integers except for borrower classification, which I dealt with later. So business intelligence is the next step, and I did some data visualizations. Here's a few that I really enjoyed. So overall, 92% of the canceled values did not cancel, and 7% did cancel, which is a pretty significant amount. And so first off, I just went to see what the data looked like. I used a histogram over all the canceled values. It looked pretty cool. It looked really neat and organized, and it was giving us a better understanding how the data values were dispersed. Next, here's some visualizations I really enjoyed, one of which was default charge compared to canceled. This one was borrower credit score compared to canceled. You got to see how these values were dispersed as well. And then borrower classification. This one didn't really have much meaning. I liked the look of it. Next, we did another group by of risk score. This one's a good one. So you can see that the higher the risk score, the more likely you are to cancel. And then this was by far my favorite, payments received. You got a good chunk of data showing that the more payments you received, in the left column, you would see that you're less likely to cancel, and the people that had lower amount of payments were more likely to cancel. And then this one was good exposure. You had more people canceling with lower exposure. Another one saying risk score, higher risk score, higher likelihood of canceling. And then this one was good, people that were registered on the web and canceling. There was less of those people than the other data sets. And these gave us a good understanding of which variables we should look out for, those being default charge, payments received, exposure, borrower credit score, risk score, and borrower registered on web. So next was exploratory analysis, meaning correlation. So first off, I got dummy variables for borrower classification to make for correlation analysis. Here's my correlation analysis. As you can see in the next slide, we did a heat map to easier visualize it. I like heat maps. It makes things better to understand and to see visually. And then after doing correlation, these were the top 6 correlated values. Top being payments received, this is a big one. Default charge was 2, had a positive correlation. Payments received had a negative correlation. Then risk score, borrower registered on web, borrower credit score, and then APR. Next we did model building. So we do classification analysis, model building first. So first thing I did was created X and Y variables. Cancellation being the Y variable. Then we did a decision tree classifier. So this one was a very good predicting. Good at predicting. We had a 94% accuracy rate under the decision tree classifier, and this is one of my better ones, and a 70% recall score, which is really good, which you can see stated here. And then we did 2 more. I did a KNN, and this one had a 93% as well, and a 73% recall score. And then next we did a random forest classifier, which was just equally as good. Not quite as good as the decision tree. That's the one I like the most. And then so we move on to regression. And regression, I created 2 more X and Y values. So in this one I used premium because that's what we're going to predict. Excuse me. And so we did linear regression feature selection. In this one, we picked out the features that had the highest correlation to our Y variable, our Y variable, which were APR, borrower registered on web, then risk score. And so that's stated here. And then I did a regression models on APR. APR was the lowest of these. I was just a 0.144 R squared value, which isn't very good, but it was better than some of the others. The best one we had was comparing all of the variables that I had narrowed my criteria down to, and that had a 0.753 R squared, which is pretty good, 75% relationship. And then our down was our highest individual variable at 75 as well, 0.751. And I did exposure, that was the second highest at 0.66. And then the model that was most highly related to the predictor obviously was containing all of the variables. Of those, the highest R squared score was down, as we mentioned earlier. And then clustering, this was my favorite by far. Clustering, we had to normalize all of our variables to begin with, which you can see here. And I used the elbow method to select my K value to decide how many clusters I wanted to use. And so I ended up getting 4 as my K value. Which here's me creating my clusters. Oop, I went too far. And those were my clusters. And so now I'm going to analyze it. So we created a little seaborne chart, and this is my favorite visualization. So really it just shows that cluster 0, everybody did not cancel. Cluster 1, everybody but about 4 or 5 people also didn't cancel. But this is the best part, is the people that canceled, almost all of them, I think like 99.5% of them are in this second cluster, which is really cool because it helps for generalization. And this is where I analyze this. You could see I put it into a little group by chart, a little pivot table, and you could see all of the variables and the averages of each category, each variable in this cluster, which was really cool for analyzing and making conclusions, which I just mentioned right here. So here's my model selection evaluation. So obviously, like I mentioned earlier, decision tree classifier is the model that I chose from classification. For predicting, it was 94% accuracy, which is really good, and a 70% recall score. and which is what I just mentioned here. And then I used the K-best model, which chose 0, 2, and 5 as the three best features. And so these three variables are default charge, payments received, and risk score. They were the most highly associated with the canceled variable. And then the clustering, like I mentioned, clustering was my favorite. You really got to see specific averages of just people that were canceled, and that was really interesting. So final analysis and storytelling. So the variable with the highest significance to being canceled are default charge, APR, payments received, borrower credit score, or borrower registered on web, and risk score. The correlation states that as default charges increase, the more likely loan is to cancel. As APR increases, as payments received from borrower decreases. As the credit score reduces in quality, if a borrower is not registered on the web, and as the risk score increases, so higher risk, all of these are more likely that a loan is going to cancel. That's what I came up with. And then doing classification analysis, I use the decision tree classifier and select K-best method to determine which variables and which prediction, shoot, I just lost my track. Which models would be the best. And so I came up with the decision tree classifier and the select K-best. And then the last one, clustering analysis. So what I pulled from clustering model is that people in cluster 2, which were all people that were canceled on loans, they had the highest default charge, the highest APR percentage, the least amount of payments received, and the second lowest credit score quality rating. Only 10% of those people in that cluster were registered on the web, which is really low, and the highest risk score were in that cluster as well. So my final suggestion, so after doing all this analysis and coming to a conclusion, my final suggestion to a financial associate analyzing loan characteristics is to keep an eye on loans with higher than average default charges, higher APR percentages, fewer payments received. Keep an eye on borrowers with lower credit score quality ratings, borrowers that haven't registered on the web, borrowers with higher risk scores, and all 6 of these, I noticed these characteristics are super significant in a loan canceling according to my data analysis. So that's my conclusion. Thank you.